Hello, welcome to this video. This is 7-1 and we are solving square root equations algebraically. This is the second video and we're going to look at a couple examples, okay? So here is the first example for this video. We want to solve this equation. Whoa, computer's freaking out. If you remember back from the first video, what we had to do is we had to go ahead and isolate your radical expression. I just want the square root all by itself. So what we'll do, whoa, the lights turned out. Wow. Lights are back on. So I have to do, I have to go run around. So we'll divide both sides by 4 to give us the square root of x is equal to 9 over 4. And then I want to square each side. Okay, so we get x is equal to 81 over 16. Okay, and this is possible. What we want to do is we want to go ahead and check this. So if I plug in 81 over 16, does this equal 9? Well, this gives me 4 times 9 over 4. The 4's cancel, and is 9 equal to 9? Yep, so there's your answer. Pretty straightforward. Here's example 2. Again, you just need to isolate your radical. So we will add 3 to both sides to get the square root of x is equal to 2. And then we'll square both sides. X is equal to 4. So we'll go ahead and check this. If I plug in 4, I get the square root of 4 minus 3. Is this equal to negative 1? Well, that's 2 minus 3 is negative 1. Yes. Okay. So we're good. All right. So here is a practice problem. Go ahead, pause the video, try this one. All right. And here is the solution. No solution. Okay. So in this case, right, you get 9. And when you plug in 9, 3 plus 4 does not equal 1. Okay, so and generally, again, a lot of the problems come around when we square a negative. All right, here is a second practice problem. Please pause the video, try this one. Okay, and here is the solution. Okay. And again, the moral of this story is just isolating your radical on one side before you square. Okay, so here is the last example that I'll do with you. And this one isn't any more complicated. It's just that we have multiple steps going on. So before I can isolate my radical, or in order to isolate, I have to go backwards from PEMDAS, right? I'm going to undo addition, subtraction. I'll add 4 to both sides. Add 4. And we get root x over 3 is equal to 5. We'll go ahead, we'll multiply each side by 3. We get root x is equal to 15. And then we'll go ahead and square both sides, and we get x is equal to, I believe that's 225. I was right. 225. Okay, and then again, just double check it. So is the square root of 225 divided by 3 when you take away 4, is that equal to 1? Well, that's 15 over 3 minus 4. Well, that's 5 minus 4, and it is equal to 1. So here is your answer. All right, one last practice problem. Please pause the video. I want you to try this example. My computer lets me. I guess not. Oh, here you go. Don't look at the answer. All right, so that is it for this video. Catch you next time. Peace. Hello and welcome to this video. This is 7-1. We are solving square root equations, and we're going to do this algebraically. I'm going to split this lesson into 2 videos. I'll do some examples and then go over some practice problems with you, and then we'll do the same thing in the next video. All right, so without further ado, let's talk solving square root equations. Now, a square root equation is a radical equation, and a radical equation is an equation, and it has to have a radical, a square root, cube root, something to this effect. So here are examples of radical equations. Note here are some non-examples below. We don't have an equal sign, or if you do have an equal sign in the second case, there is no square root. The third example, again, that is a radical, right? It's to the power of 1/2, but there is no equal sign. It's not an equation, okay? All right. Radical equations, we are going to follow these steps, and then we got to check for something. So with square roots, right, funny things happen. Okay, so here are the steps to solve a radical equation. First, isolate your radical expression. I want to get rid of everything except my radical expression. Okay, then we'll raise both sides to the appropriate power. So if I'm working with the square root, I'll square both sides. If I'm working with a cube root, I'll cube each side. Third, solve the resulting equation. Okay, and it's important to note, just know if you're working with a linear equation or a quadratic, right, and how you solve those. Okay, step 4, check for extraneous solutions. This is very important, and then we'll write our final solution. So what are extraneous solutions for radical equations? Well, these are solutions that fail to make the left side and the right side equal to each other, or they create imaginary values when substituted back in. Okay, so we'll just check this. You're not going to really like this because you need to check your answers, but we'll plug it back in. Okay, so without further ado, let's go ahead and look at a basic example. I have a radical equation, one term on the left side. Okay, that's a radical, and I already have it isolated, so I can just go ahead, I can square each side, and we get x equals 16. So there's your possible solution. But what I want to do is I want to go ahead and check. I'm going to plug this in. I'm going to plug in square root of 16. Is this equal to 4? Well, 4 is indeed equal to 4. Yes. Okay, so this is our solution. X is equal to 16. Here's example 2. I have the square root of x minus 2 root 3 equals 0. Well, again, to solve this, I just want a radical on each side. So I'll add 2 root 3 to both sides to isolate the radical. So we get the square root of x is equal to 2 square root of 3. We'll go ahead and square both sides, giving us x is equal to 4 times root 3 squared, so that's 3, which is 12. So I'm going to go ahead and check. I'm going to plug in the square root of 12 minus 2 root 3. Does this equal 0? Well, 12 is 2 root 3, and 2 root 3, yep, left side is equal to the right side. Check. Okay, so our solution is x equals 12. Okay, so these are all linear examples, right, where my radicand, the variable, is linear. So check this out. Here's a kind of a weird situation. When I square example 3 here, we get x is equal to 25. So note that I plugged in this example, okay, and I squared a negative. Some bad things are going to happen when you square a negative, but I'll go ahead and I'll plug this in. So I get the square root of 25. Is this equal to negative 5? Well, no, the square root of 25 is just 5. Okay, doesn't equal negative 5. So this is extraneous. Extra, right? Throw it away. Bye. Okay, so what's your answer? Well, your answer is no solution. Who has their phone on? No solution. Or you can say the empty set, right? No solution. All right. Okay, I think that is it for examples for this video. I think they were all linear examples. I do have some practice problems for you. So I want you to try this. Please pause the video, actually pause it, try this example, okay? All right, so hopefully you paused it and tried it. Here is the solution. You should have gotten 81, and it is not extraneous. So there you are. Here's example 2. In example 2, please pause this, or practice 2, please pause this, give this one a go. Okay, so hopefully you watched that. Here is the solution. You should have gotten 32. Okay, and I think that is it.